All right, guys, this is our last lesson for section 5.3, and it's broken into two pieces. The two remaining pieces, one section is a true-false section, the other one is an identities section. But don't get spooked, the identities are not that bad in this section. So what I want to do is I'm going to get rid of this first section. Let's talk about that. This is the true-false section. So what they're going to do is, for example, they'll give you something like this. They'll say cosine of, what the heck, 47 degrees is equal to the cosine of 20 degrees plus 27 degrees. And I would say that is a true statement. There's not any real work to show in this section. There's not a ton of work to show here. It's either true or it's false. But they might try to do something like this, like cosine of 47 degrees equals cosine of 20 degrees plus cosine of 27 degrees, something like that. Well, that would be false. See, this first statement is totally true. I could rewrite 47 degrees like this. I could write it in parentheses. But if I wanted to rewrite it in parentheses, this is definitely not valid, because if I was going to do the expansion, I would say cosine of 20 degrees times cosine, whoops, why did I do that, of 27 degrees minus sine 20 degrees sine 27 degrees. Now that would be the same thing as this right here. So that section, you're going to run into some stuff, and guess what? It's going to be true-false information. So I took this one example and I turned it into basically 3 examples. So let's just, what if they gave me something like this and they said, be on the lookout for, what if they did cosine of 20 degrees, cosine of 10 degrees, I don't know, minus, minus sine, I meant to write sine 20 degrees, sine 10 degrees is equal to cosine of 10 degrees. Would that be true? Well, this would be written as the expansion, and since it has a minus in the middle, this would be the same thing as cosine of 20 degrees plus 10 degrees, which would give me cosine of 30 degrees, which would not equal this. So once again, this would be a false statement, So it's true or false. This section is true or false. Now, one of them is going to try to be sneaky. Let me just show you one that I think is sneaky. So this will be my last example because, like I said, this section is just, is it a true thing or is it a false thing? So here is where they're going to try and trick you. So let's do this guy right here. We're going to do that equals cotangent x. And you might look at that and say, I think it's true. You might look at that and say, I think it's false. Well, it's one or the other. I'll give you that. But here's why I think this one is sneaky. They're trying to be tricky. This looks like what we call a co-function identity. I think those were on page 207, the co-function identities. And those were the ones where they said, like, tangent of 90 minus theta equals cotangent theta, right? And then in that little tiny tan box on our on page 207, they also said if you want, you could convert this to radians, and if you don't want to use theta, you could use an x, and then you could write it like that. That would be valid. This is the co-function identity, but what I want you to see is if this is equal to cotangent, this is it, right? How can both of these things be equal to the same thing but be different? Both of these guys are equal to cotangent? Come on. Well, then they better match. And it's very subtle, but do you see they don't match? Pi over 2 minus x is not necessarily the same thing as x minus pi over 2, right? It's like if I said, what's 6 take away 2? It's not the same thing as 2 take away 6. It's not. So I would have to say this one is false. So be careful. They do try to trick you with the true-false section here. But really, there's not much stuff, just a little bit of logical play, and you'll get it. Now, the second part, though, is identities. The second part you're going to face is identities. And whenever I say identities, that's when oh no. And here, I'm just going to tell you, this is one of the problems. You can skip this one when you come to it, but I wanted to do it because it happens to contain a secant. And I have to clue you in on this. This is the identity. They want me to prove that the stuff on the left is equal to the stuff on the right, and I am going to do a left-hand only proof of this. But here's the sneaky thing they don't tell you. There is no secant sum or difference formula. But what is secant? Secant is the reciprocal of cosine. So I can rewrite this side right here as 1 over cosine pi minus x. Then, like I said, I'm just going to work on the left-hand side of this only. I could write this as 1 over cosine of pi times the cosine of x plus sine of pi sine of x. Now, if I look, this is me, I always tell you, if you have a cosine graph, boom, that's as far as I have to go. There's 0, there's pi over 2, there's pi, right? Well, what's the cosine of pi? It's -1. So this guy is -1 times, what is this guy? Cosine of x. And this is just me making a real quick sketch of a cosine graph. And then I'm going to do the same thing with a sine graph. I'm going to go like this. Sine, hey, guess what? Boom, right here. That would be 0. That would be pi over 2. That would be pi. What is the sine of pi? I don't even need a calculator. It's 0. So 0 times sine x. So what happens in this problem is I get 1 over negative cosine x, because these guys would cancel each other out. And then I say unto myself, hey, that is just a fancy way to say negative secant x. And voila, I am done. I have proven this identity. So here's the thing. When we first start working with identities, we don't know that much information. So it's a struggle. It's a learning curve, and it's pretty steep. But the more you actually know, the easier these things become, because you can recognize, hey, first off, in this one, there's no secant formula, but I can do 1 over it, 1 over cosine. And then what is that? That's just expanded out. Once I expand it out, I can, hey, there's my guy. Cha-cha, da-ding, there it is. So when we start going into these type of identities, these are what I call, computational computational meets theoretical. This is when we kind of use, hey, I know there's a formula. All I have to do is plug everything in the formula correctly, and if I clean it up, I'm going to end up with my identity being proven. So this is valid. That's my proof. I'm done. And that took me what? That took me 1, 2, 3 steps to get to the end. It wasn't a very bad proof at all. So, guys, here's what you're going to be doing. This is the very end of section 5.3. 5.3 is finally done. So in your book, you'll see this. Oh, darn it, I don't have my book on me. I think this is, hang on. What is it? This is page 213. So this stuff right here is page 213, section 5.3. These ones here are true, false. And you'll see there they are, 51 or 57 to 66. And then down below, there's the answers for those. So pause it, take a picture of it. And then the other part that I want you to do, the other part of the assignment, oh, did I bring it in here? I don't think I did. Nope. It's just on the bottom of that same page. So let me just write it here. So right here, this part is true, false. And then right below that, you'll see problem 67 to 70. These ones right here are identities. So there is no answer key for them. You are the answer key for them. But these identities, remember, I already did number 68. So you only have 3 identities to mess with there. All right, we are finally done with section 5.3. Woo! Took long enough. Took long enough. All right, have a good one. Bye-bye.